Good morning, students. Welcome to JGS online class for grade 12 physics. Let us start with the chapter 1, electric charges and fields. Electricity is of two types, frictional electricity, or it is also called as static electricity. And the second one is current electricity. So what is the difference between these two? The electricity which is developed in the objects by rubbing or by friction is called frictional electricity, and the rubber substances which show this property of attraction are said to be electrified. So how can we define this frictional electricity? It is the electricity produced by the electric charges at rest is called frictional electricity. Similarly, the other one is the current electricity. So what is meant by current electricity? If the charges are at rest, then the electricity is considered as static, and if the charges are in motion, the electricity produced by the electric charges in motion is called current electricity. I think you might have understood the difference between static and current electricity. So in this chapter, let us learn about the static or frictional electricity in detail. Actually, in 600 BC, the Thales was a scientist who was one of the founders of Greek science. He first noticed that when a piece of amber is rubbed with a woolen cloth, it has acquired some property of attraction and it started attracting the pieces of leaves and tiny feathers, etc. In 1600 AD, the William Gilbert was the scientist and he made a systematic study of substances which behave like amber. So there are different substances which have behaved like amber. And what is an amber first of all? It is a yellow resinous or gum-like substance found on the shores of seas, usually at the Baltic Sea. The Greek name of amber is called electron, which is the origin of all such words like electricity, electric force, electric charge, electron, etc. Usually we will be listening. So now let us learn what is an electric charge. Okay, so what is an electric charge? Usually we know different particles like elementary particles such as electrons and protons, they will have some electric charge. So what is an electric charge? It is an intrinsic property. Intrinsic means the property present, natural property of some elementary particles like electrons, protons, etc. Usually we know electrons carry the positive charge and protons carry the negative charge. It is only because of these electric charges that various objects they exert strong electric forces of either attraction or repulsion on each other. Thus, the electric charge is an intrinsic property of the particles of matter, usually which gives rise to electric force between different objects. So what is an electric charge? We understood what is an electric charge. It is considered as an intrinsic property of different elementary particles present in the matter. Electric charge, it is considered to be a scalar quantity. You know very well, all the physical quantities are divided into two types. Okay, those are scalar quantities and vector quantities. So let us once remember what is the difference between the two. What is a scalar quantity? It is only having the magnitude without any direction. So usually we will bring all the physical quantities into the group of scalar quantities if they have or if they possess only magnitude without any direction. But vector quantities are those which possess both magnitude as well as the direction. So what are the examples of scalar and vector quantities? Scalar quantities examples are speed, distance traveled, etc. So in case of either distance traveled or speed or force, etc., we will consider only magnitude, but its direction will not be considered. But in case of velocity, displacement, etc., both magnitude as well as the direction will also be considered. Okay, so that's why this electric charge, particularly the physical quantity which we are discussing about, is considered to be a scalar quantity, and its SI unit is coulomb. So, coulomb is the SI unit of electric charge, which is a charge of one elementary particle, that is either of electron or of proton. We know very well atom is electrically neutral. It consists of number of protons equal to number of electrons. That means that each and every elementary charged particle will have, either it is a proton or electron, will have equal charge, which is equal to 1.6. So, the charge of electron is equal to 1.6 into 10 power minus 19 coulombs. 10 power minus 19 coulombs. So, this is about the electric charge. Now, let us know about the electrostatics. So, electrostatics is nothing but frictional electricity. It is the study of electric charges at rest. Now, we study the forces, fields, potentials associated with the electric charges in the static electricity. There are different applications found in industrial purposes in case of electrostatics. Like, what are the different applications we usually observe? They are used in electrostatic loudspeakers, electrostatic spraying of paints and powder coatings, and in ash collection in chimneys, Xerox copying machines, and in the design of cathode ray tubes used in the television, radar, etc. Thus, there are different applications of electrostatics in industries. Now, let us see the different kinds of electric charges. What are the different kinds of electric charges? We know very well there are two kinds of electric charges. One is positively charged and is negatively charged. So, there are only two kinds of electric charges, positive and negative. And the properties of the electric charges are like charges repel and unlike charges attract each other. So, the the second one, the properties 1 and 2 is that is like charges repel and unlike charges attract. This statement is known as fundamental law of electrostatics. Now, let us learn about the different experiments conducted by the scientists to understand the properties of electric charges, right? Now, in this experiment, let us see the two kinds of electric charges. About 100 years ago, Charles Jouffroy, a scientist of France, he has conducted this experiment by taking the electric charges on various objects of different kinds, of two kinds of electric charges by using different objects. Like how different objects are electrified by him, let us observe first. Okay, now in the first experiment, he has taken a glass rod and a silk cloth. So, here there are four objects used. Please try to understand clearly. One is glass rod and the silk cloth. And second one is plastic rod and the wool. When a glass rod is rubbed with the silk cloth, glass rod will acquire the positive charge. Similarly, when a plastic rod is rubbed with the wool, plastic rod will acquire the negative charge. Otherwise, directly if you bring without rubbing, when you bring the glass rod is neutral, electrically neutral. Similarly, without rubbing with the wool, plastic rod is electrically neutral. Now, we have electrified the glass rod and he has electrified the glass rod and the plastic rod. Glass rod has become positively charged by rubbing with the silk cloth, and similarly plastic rod has acquired the negative charge by rubbing with the wool. Now, two electrified rods, one is glass with positive charge and other is plastic with negative charge. Now, we can clearly observe this in the picture. Okay, now let us see the three different cases in which the experiment was conducted here. In the first case, rub a glass rod with the silk and suspend it from a rigid support by means of a silk thread. Bring another similarly charged rod near it. That means another similarly charged glass rod near it. The two rods we have observed, both of them have repelled each other. That means the charge present on the first glass rod and the charge present on the second glass rod, both are same and same charges, they have repelled each other. This is the case 1. Now, in the case 2, already the glass rod is suspended, glass rod which is positively charged is already suspended from the silk thread. Another rod which is plastic which has acquired the negative charge by rubbing with the wool is brought near here. Then what did we observe? There is an attraction between the glass rod and the plastic rod. It shows that the charge present on the glass rod is different from the charge present on the plastic rod. Right? Now, let us see the third case. Now, rub a plastic rod with wool and suspend it from the support. What support? Silk support. Okay, silk thread. Now, the plastic rod which was hung is having the negative charge. Bring another similarly charged plastic rod near it. There will be a repulsion between these two rods. Clear, all of you? Now, in the above experiment, it is clear that the charges are transferred from one object to other object. Like the charges, glass rod is rubbed with the silk cloth. So there is transfer of charges between glass rod and the silk cloth. Similarly, plastic rod and the wool, when there is a static friction between these two objects, there is again a transfer of electrons from one object to the other. Clear? Now in this experiment, let us see the experiment 2. Let us take 2 pith balls and hang it from a silk thread. These 2 pith balls, initially they are neutral. Now, take a glass rod rubbed with a silk cloth which acquires positive charge and then bring it in contact with the 2 pith balls separately, so that both the pith balls will acquire positive charge. And in the experiment A, in case A, it is observed that both the pith balls have acquired the positive charge when they are in contact with the glass rod, and both will move away from each other. Similarly, in the second case, bring a plastic rod rubbed with the wool in contact with the pith balls separately, so that both the pith balls will acquire the negative charge, and again repulsion is observed in this case also. Now, in the case 3, suspend 2 pith balls separately and bring a glass rod rubbed with a silk cloth, or we can also say charged glass rod. You know, charged glass rod, what charge does the glass rod is acquiring? It is acquiring positive charge. So, charged glass rod is brought in contact with the first pith ball, and charged plastic rod is brought in contact with the second pith ball, so that first pith ball will acquire the positive charge and second pith ball will acquire the negative charge. And it is observed that both of them have attracted each other. Right? Now, from this experiment, from the above experiments, we can also demonstrate that charges are transferred from the rods to the pith balls on contact. So, we can say that pith balls have been electrified or they are charged by contact, because they are getting charged by the contact only. This property which distinguishes these two kinds of charges is called polarity of charge. What is that, students? It is called polarity of charge, and this is the property which is separating the two kinds of charges, which is called polarity of charge. Now, Benjamin Franklin, an American pioneer of electrostatics, he introduced the present day convention by replacing the two terms positive charge and negative charge separately. So those are, according to him, the charge acquired on the glass rod when rubbed with silk is positive, and the charge developed on plastic rod when rubbed with the wool is called negative. So he was the one who stated that the glass rod is acquiring positive charge and the plastic rod is acquiring negative charge through friction. Right? Now let us see the frictional theory or electrostatic or electronic theory of electricity. What is this theory? What is the frictional theory of electricity? Why one rod when it is in contact or rubbed with the other object is acquiring charge? What is this? How it is happening? This is understood when we go in detail with the intrinsic properties of atoms, right? We know very well about the structure of atom. Atoms are made up of elementary particles such as electrons, protons and neutrons. And we know the individual properties of electrons, protons and neutrons. Electrons are having negative charge, protons possess positive charge, neutrons are electrically neutral, and the heavy or densely massed particles are protons and neutrons, and these protons and neutrons are present inside the nucleus. That is the reason why the nucleus is said to be having more density compared to the density of atom. Right? Now, electrons are the lighter particles. They will be revolving around the nucleus. In any piece of matter, the positive charged particles equal to number negative charged particles. That is the reason why, that means we can say that the number of positive charges is equal to the number of negative charges, and that is the reason why the matter in bulk is considered to be electrically neutral. Okay, so that means the magnitude of charge on electron and the magnitude of charge on proton both are same, right? So we can say we have already understood the charge of electron or proton. Its magnitude is 1.6 into 10 power minus 19 coulombs. Now we can say charge of electron is minus 1.6 into 10 power minus 19 coulombs and charge of proton is plus 1.6 into 10 power minus 19 coulombs. So it shows that both of them are differently massed particles but same charged particles having same magnitude, but charge is only different, right? Now these electrons, as we have already understood, electrons are present in the atom moving around the orbits around the nucleus. Okay, so these orbits are already present around the nucleus. Electrons will be moving around in the particular orbits. The electrons which are away from the nucleus are considered as valency electrons. The electrons which are present in the outermost shell are considered to be the valency electrons, and the force of attraction between these valency electrons and the nucleus is comparatively less. So that electrons in the outermost shell of atom are loosely bound to the nucleus, and the energy required to remove an electron from the surface of material is called as work function. So each and every matter will have some work function. So when certain work function is given to that particular object, it will loses the electrons, right, from the outermost orbit. So when two bodies are rubbed against each other, electrons are transferred from one material to the other material. So how it will transfer? From the material with lower work function to the material with higher work function. Now what is meant by work function? It is the energy given to the object to remove the outermost electrons. For example, let us take in the case of glass rod and a silk cloth. When you rub the glass rod with a silk cloth, it is understood from all the above experiments, we are understanding that glass rod is acquiring positive charge and the silk cloth is acquiring the negative charge. So what is happening here? It is easy to remove electrons from glass rod by using the silk cloth. That means the work function of the glass rod is less compared to work function of the silk cloth. When both are under friction, what is happening? The electrons present in the outermost orbit of glass rod are getting transferred to the silk cloth. Let us suppose initially there are 10 number of electrons on glass rod and 10 on the silk cloth. So after friction, few electrons from the glass rod will transfer to silk cloth. Let us suppose 8 electrons are there on the glass rod and 12 electrons are there on the silk cloth. That means before friction, the total number of electrons on the glass rod as well as on the silk cloth is equal to 10 plus 10, which is equal to 20. After the friction, the total number of electrons on glass rod and silk cloth is 8 plus 12, that is also 20. That means there is no increase or decrease of electrons. There is just transfer of electrons from one object to other. So, from which surface to which surface electrons are transferring? From lower work function, the object having lower work function to object having higher work function. So, glass rod is having lower work function and silk cloth is having higher work function. That is the reason why electrons are transferring from glass rod to silk cloth. The one which is losing the electrons will become positively electrified and the one which is gaining the electrons will become negatively electrified. Right? Similarly, in the case of plastic rod and the wool also, when the plastic rod is rubbed with the wool is having lower work function here and plastic rod is having higher work function. So, wool will lose the electrons, plastic rod will gain the electrons. That's why plastic rod is becoming negatively charged and wool is becoming positively charged. Right? So, the combined or total charge of the two objects is still 0 and it was before rubbing is equal to after rubbing. That is, total electric charges before rubbing is equal to total number of electric charges after rubbing. This shows that the charge is conserved. What is meant by conservation of charge? So, according to the static electricity, the total number of charges before friction is equal to total number of charges after friction. There is no gain or loss of loss of charge. Only the charges are changing their surfaces. It is changing from one surface to other surface, making one object positively electrified and other object negatively electrified. So, the only way by which an electron can be pulled from an atom is to exert a strong electric force on it, right? Now, as the electrons are actually transferred from one body to another during rubbing, frictional forces must have electric origin. So, this theory explains us that the frictional forces is having the electric origin.